In this video, I further explain projection-based apprenticeship learning. Apprenticeship learning means an agent learns his policy from expert demonstrations. To do so, apprenticeship learning uses two steps to learn the policy. First, use the inverse reinforcement learning, learn the underlying real-world function from the demonstrations. And then use this real-world function in the reinforcement learning to find the optimal policy for agent. So in the first step, we need to use the reinforcement learning to solve this optimal problem. Here, this mu E is a feature expectation of expert policy, and this mu is a feature expectation of the learned policy. In this, use this minimum operation, that means we find a policy that has a feature expectation close to the expert's value. That means we find the optimal policy that is close to the expert policy. So once we have this optimal policy, then we find the W. And then we find the maximum real-world function for this optimal policy. And once we have this real-world function, then we use this real-world function in the reinforcement learning to find the optimal policy for our agent. Here, let's see the how can we use the projection method to find the real-world function, and in turn to find the optimal policy. First, this T terminate this iteration if T is smaller than a criterion. Here, this mu bar is a policy in this the policy that is close to this expert policy. First, we just randomly pick up a policy and calculate its mu value. Because right now we only have 1.1 policy, so this policy equal to mu bar. Once we have this mu bar and the expert policy mu E, and then we can use the mu E and the mu bar to calculate this parameters W. So from this W, we can calculate the real-world function. And then we use the real-world function in the reinforcement learning to find the policy pi 1. This is the first step. In the second step, we use this mu pi 1 in the next step to calculate mu. Once we have this mu, and we already have this mu 0, so we can calculate the projection, and it is project this mu E to this mu 1, mu pi 1, and this mu bar. And we can find the policy mu bar 1 that is close to the expert mu E. Once we have this mu E, and then we use this mu bar E and expert mu E, and then we calculate from here, we calculate W using the inverse reinforcement learning. And then we use this W to find the real-world function R, and use this real-world function in the reinforcement learning to find the next policy pi 2. And then in the third step, we use this pi 2 to calculate the mu pi 2. Once we have this mu pi 2, we have a mu bar 1. And then we calculate the projection from this mu E to this line. That means we need to find the policy mu bar 2. that is close to the expert policy. From this mu2 bar, and then and this mu-e, and we can use it from here. We use the inverse reinforcement learning to calculate this W3. From this W3, and we calculate the real-world function, and then use this real-world function in reinforcement learning to calculate the pi3. And then we send this pi3 to the next step until we reach the terminal condition to stop the iteration, find the optimal policy. For more details, please check with this reference. Thank you. Bye.